Howdy everybody, welcome back to my office. And we're going to do some more statistics. And I like to think of this as just hanging out and doing statistics and figuring it out together. So learning not only about statistics, but also learning about how to learn. Learning about how to learn. It's maybe the most important skill of all, because if you don't know how to learn, you're stuck. And if you do know how to learn, you're going to move forward. Thankfully, all of us are born with an innate, it's born, it's within us, it's inside us, an innate ability, an ability that is within you that knows how to learn, right? So you have an innate ability to learn, and you could improve upon that, but look at everything you've learned already. Right? Like you were born and you didn't know how to speak, you didn't know how to walk, you didn't know how to talk, you didn't know how to walk, you didn't know how to talk, you didn't know how to pick things up, you didn't know how to throw a ball, you didn't know how to catch a ball, you didn't know how to run. And so look at all the amazing things you've already learned just with that right there. So you were built to learn, you know how to learn, and but also we can improve upon how we learn. And so that's part of what you'll see in here is how I learn, because I'm new to statistics, took it as an undergraduate, took it as a graduate student, and got an A when I was a graduate student. I don't remember what I got as an undergrad, but I do remember I did not understand it. And so now I've been asked to teach stats. It's my second semester teaching it, so I'm still kind of figuring it out, but we're figuring it out together. And in addition to learning about statistics, you're learning how to learn, because you're going to see how I figure stuff out. So we're moving into module 12 here, chapter 12. And some of the stuff that's going to be covered, you can see it there in green, is tests of goodness of fit, independence, and multiple proportion. So that will all become clear as we go through it. And I really like to kind of just start out by an example, but like this is some of the stuff we want to learn. So let's say that there's like 3 companies who share a market. They're selling something, who knows what. And the probability of a customer going in and buying one of these products, whether it's product A, product B, or product C, is 30, 50, and 20, right? So you could say that company A, product A, has 30% of the market share. 30% of the time customers buy that. Product B, company B, has 50% of the market share. So we have product A, product B, company B has 50% of the market share. And company C, and product C has 20% of the market share. And so what we want to know is if like one of these companies, releases a new product. So the new product, where's the new product coming from? Company C. Okay, so company C is going to release a new product. So they're going to test that on 200 customers. And they're going to see to the 0.05 level of significance. So with 95% confidence, they're going to see if they change the market share, if sales actually increase for the new product C, and if that takes away sales from product A, product B, company A, company B. Well, that's kind of a cool thing, right? So we're going to do, some of that, and we're going to learn about goodness of fit tests of independent, testing for equality of 3 or more population proportions. So in this chapter, we introduced 3 additional hypothesis testing procedures. The test, statistic, and the distribution used are based upon chi. We learned that chi-square. We learned how to pronounce that. If you ever don't know how to pronounce something, watch the previous videos. Or, here you go. If you want to know how to pronounce chi-square. Chi-square definition, here it is.
Chi-square.
Chi-square. There it is. And in all cases, the data are categorical. So if you remember when we were learning about how to, think about different types of data, we learned about NOIR. And NOIR, stood for nominal, ordinal, interval, and ratio. And so these were different categories of data. And then we also had categorical or qualitative. And then we also had quantitative. And so these were qualitative, aka categorical, generally speaking. Those two were right there. And then these were quantitative, right? And that these are more likely to be numbers, and these are more likely to be like it, don't like it, Pepsi, Coke, right? Some sort of a category. They were categorical. And so you can go back and watch those previous videos if you need to review that, but that's a little bit of a review right there. And just to de-emphasize this, I'm going to make it like smaller, like this is just a reminder note right there of those things. So there you go. So, and then what we're going to focus upon here, like that's a little introduction. Tempted to leave this video just like an introduction, but I'm also tempted to just keep rolling. I think shorter is better, so that's always the rule of thumb if I'm on the fence. So I'm going to leave this video as the introduction, and we'll just call this an introduction to all of that. And in the next video, we're going to jump in and do goodness of fit test multinomial probability distribution. See you in the next video.